Imagine a towering 100-foot-high lava flow slowly advancing towards you, moving at a slow speed of less than 100 feet an hour. While this might not sound like something which could occur within Nevada, it actually did within the state only 110,000 years ago. The state of Nevada is known for many things, but in the geologic sense, volcanoes are not among them. And yet, the state contains several volcanic complexes which are quite likely to erupt again at some point in the future. While Nevada is by no means as volcanically active as Iceland, where lava has erupted onto land 3 times in the past 3 years, the state does contain 5 volcanic areas of interest. The most notable of these being a series of explosion craters near the town of Fallon, which formed within the last 6,000 years. While this complex known as the Soda Lakes volcano is the most likely region of the state to erupt again, Nevada also contains 4 lesser-known dormant volcanoes. One of these is a little-known complex that straddles the border of Nevada and California. Known as the Aurora Bodie volcanic field, it has been erupting intermittently since 3.6 million years ago. During this time span, it has produced 50 distinct vents, with an eruption occurring an average of once every 72,000 years. Unlike the other volcanic fields within Nevada, Aurora Bodie does not primarily erupt runny basaltic lavas, as instead, more than 90% of its erupted lava has created towering blocky lava flow lobes 150 feet or more in height out of basaltic andesite and andesite, in addition to towering dacite and rhyolite lava domes. The most recent of these vents produced the nearly 4 square mile Mud Springs lava flow. It was in place during a mildly explosive eruption 110,000 years ago, oozing from a cinder cone only after ash emissions had ceased. So, why is Aurora Bodie one of only 2 volcanoes within Nevada to have primarily erupted such high silica lavas? The answer relates to 3 factors: the basin and range province, the thickness of the crust, and how long the volcano has existed for. The Aurora Bodie volcano is located at the very edge of a region of tectonic spreading to the east and west known as the Basin and Range Province. This province is why large swaths of Nevada, western Arizona, and eastern California have topography which largely looks the same. The slow extension creates a series of large fault lines in the crust, creating uplifted patches of land known as horse and subsided patches of ground known as grabens. Over millions of years, this process created large mountain ranges and valleys. Upwelling mantle material then used these faults as a path of least resistance, creating magmatic intrusions, some of which eventually erupted onto the surface, forming scattered volcanic fields. In the case of Steamboat Springs and Aurora Bodie, this occurred in a section of the crust which is about 5 miles thicker than surrounding regions. This thickness allowed for intruding magma to over time incorporate some more silica-rich rock into its mass, becoming more viscous and silica-rich. Third, there is a distinct possibility that a magma chamber of some sort still exists, perhaps more than 15 miles deep in the crust beneath this volcanic field. At such depths, failed magmatic intrusions can take tens or even hundreds of thousands of years to cool. Yet, as this occurs and the material cools, higher temperature minerals that are poor in silica crystallize out of solution in a process known as fractional crystallization, causing the magma to change in composition to eventually become andesite, dacite, or even rhyolite. Towering peaks such as Mount Hicks and the smaller Cedar Hill are deeply offset by what appear to be large fault lines. At the basaltic andesite Mount Hicks, one such offset reveals a layer of darker colored and less silica-rich basaltic lava rocks on the bottom. This further supports my assertion that magmas largely became more silica-rich over time. While some papers claim that Aurora Crater is a Yungas vent with a claimed age of 25,000 years, I believe this date to be incorrect. Rather, it is 250,000 years old, representing the second last eruption in the overall complex. Aurora Crater represents a 4.3-mile-long andesite shield volcano which at one point produced a landslide that caused parts of its central cone to collapse to the north, leaving behind a collapse scarp. In my opinion, the odds of the Aurora Bodie volcanic field erupting anew are quite low at about 1 in 72,000 each year. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.